Hello, and thank you so much for having me. And thank you for the introduction. There's a small, very minor uh, glitch in my introduction. I have a master's and a PhD degree from Waseda University, not just a master's degree. Okay, so I'm very happy to be here with all of you. And I hope it will be the beginning of a long-term collaboration and cooperation with the scholars and researchers here. So basically, I'm gonna start my topic from a kind of non-numerical perspective of what we do as researchers. I'm not sure if you are familiar with this symbolism. Basically, here what we are seeing is a big elephant, of course, we can all see that. But if we look at the individuals who are really close to this big elephant, each one of them cannot see or actually identify the elephant in a different way, in a non-true way, in a false way. So those who are close to his body, they think it's a wall. Those who are close to his hose, or trunk, they think it's a hose. Those who are close to his ears, they think it's a fan, and so on. So the reason why nobody is capable of actually realizing what this is basically because they are so close to the reality that they lose the overall view of what this item is. And this is extremely important when we are dealing with statistics and numbers. Numbers cannot be viewed in a very narrow way. It has to be accompanied with the whole scenario, with the whole narrative that we are working on in our research. We cannot isolate. We cannot say, okay, well, we need to have really good numerical figures, but at the same time, my assumptions or my hypotheses or my conclusions or my analysis or my discussions, they are flawed. They have to be all part of the coherent, well-established narrative that we are presenting for the readers. Many make the mistake of assuming that the graph and the narratives or the numbers are the end result of their studies. And this is not true. So numerics and graphs and analysis is just one simple block that is sometimes you're required to do to achieve this whole comprehension, to understand and to be able to see what you are dealing with from a distance, to actually be able to realize the elephant for what it really is and not just part of the problem. Okay, so what I'm going to talk today about. So my presentation is dissected into 4 different parts. In the first part that I'm currently in right now is the introduction. Okay, so I will introduce the dilemma of reporting statistics. Is 3 or 4 slides, and then we will go in depth in analyzing or understanding what kind of statistical issues or mistakes that we do or some journalists do in non-statistics related articles. Okay, so this is also quite common, and we will tackle that. In the third section, we will understand how we are supposed to report statistical results in a professional way in academic journals and in other research papers. Finally, there is a small section on statistical reporting and AI. Okay, so let's just jump right into it. Look at this slide here. I don't want you to read the text, okay, but just look at this slide. Most of you will agree. Usually, if this is an interactive session, I will ask you the question of which one you think is easier to understand. But I think most of you will agree with me that the graph to the right is easier. Okay, it's more intuitive. You can just get the point from it really quickly. And this means that the graph on the right fulfilled its purpose. It was able to convey certain message to the readers better than the text format of the same story. So the data on the left and the data on the right, they are exactly the same thing, but the data on the right are better presented. So, and this cannot be said, for example, in this case. Also look at this graph. You will see we have a very sophisticated graph to the left-hand side. We have it's 3D, it's fancy, and it has a lot of numbers. Okay, but is it really what we want to convey? all what we wanted to say in this graph is that 30% of the staff nurse in a hospital are males. That's it. Do we really need to do all this complexity that was mentioned on the left-hand side of the slide? Most likely not. It's a waste of effort, waste of time, waste of space in our articles. So this goes to say that when we are trying to represent figures and numbers, it's not always the better approach is to make it more complicated and more sophisticated and make fancy graphs. It's not usually the right way to do it. What we need to think about, what is the best way to convey a certain message that we want to deliver to the readers. This is what should be our #1 priority. Together with that, with the representation of the figures and numbers, many times we also do the mistake, and this is what we call mutant statistics. Okay, so we put some figures, and then those figures, if you just state that statement in a slightly different way, you will have a very different meaning. And we have many such examples in everyday articles that we read. Here I mentioned 3. So if you look at the, or actually mentioned 4. So if we look at the first statement at the top, we see, let me just put a pen. I think that's easier for me. Okay. So every year since 1950, the number of American children gunned down has doubled. Okay. So this was reported as a bad type of reporting of statistics, because if actually this is the case, then by the year, I don't know, like by the year after 10 or 15 years, then the number of children gunned down will be in hundreds of millions, okay, maybe even a billion or 2. So actually there was a wrong statement in this of statistics in this statement on this phrase. What they really wanted to say is that from year 1950 up to the year that this statement was written, the number of American children gunned down has doubled. So if it was in year 1950, there were 10 people who were gunned down. So let's say by year 1995, when this, for example, this article was written, now we have 20. If the number of children gunned down in 1950 were 10. Okay, so that was the implied meaning, but because of the mistake in writing down the statistics, this was not the right approach. Another example, the second statement, the cost of a telephone cell phone has decreased by 12,000%. So if something, the cost of something decreased by 100%, so now the cost should be 0. Okay, so this of course should raise some red flags directly. Okay, there's no way that something like the cost of telephone call has decreased by 12,000%, then because it will become a negative. Okay, so of course there was a mistake in calculating the percentage using in this statement. And we have so many different examples, other examples of misrepresentation using statistics, and usually those are like people actually consume them and they don't really get any scrutiny, okay, from the public. Maybe because they don't understand them, maybe because they just accept figures because they don't maybe have the time, they don't have the will, and they maybe sometimes, because we are dealing with some social issues, sometimes we tend to believe it. Okay. All right. So this was my introduction. In the second segment in this presentation, I'm going to talk about statistical issues in non-statistical publications. So I spotted 7 different reasons why people make problems or mistakes in those reports. First, we have the estimations. So many journalists go to estimations. They don't really report accurate figures. And we'll see why this will happen and why this spreads. And then the second issue is the problem definition. The third issue is the measurement, then the sampling, then data organization, statistical techniques used, and finally we have the interpretations that they use. So first, estimations. Okay, so for example, look at this title here. We have 1 in 4 women experience domestic abuse. Okay, so basically, if we dig deeper into this part here, okay, so analysis of 366 studies involving more than 2 million women and so on and so forth. So apparently, what they are doing here, they are summarizing 366 studies, okay, and they came up with the ball figure ballpark figure, which is 1 in 4 women experience abuse. How was this summary made? Okay, could we bring those different articles in different contexts, in different locations, and we sum them up like this? Okay, most likely not. Okay, but most people will not really question that. Okay, most people will just accept this huge estimation and just go along with it. And it's really big number, like 1 in 4 women. It's just a huge that you can make news. People will start talking about it, and that's actually the intention of making such a big title. Okay, so the reason why these figures are not contested is because they blame you. If you contest those figures, they will say, okay, well, you have some hidden agendas, and because you are against women's rights, and so on and so forth. Okay. Another reason why people assume such estimations are accurate is because, well, maybe they don't know anybody in their circle who's being abused, but they will always say, you know what, the situation is always worse than what we see. There's always something more catastrophic than what we actually see. So that's another reason why we don't contest it. And another reason is the self-enforcing nature of those figures. Because if this article published this number, there will be some other articles who will actually do something similar, maybe based on similar articles, or they will come up with some, they will base their new figures on this exact articles, and then this will solidify this opinion. Okay, and this is actually why these estimations are not contested enough. The other issue with problem definition, if we go back to this problem here, or this title here, domestic abuse. What does domestic abuse mean? What is domestic abuse? Okay, is it physical? Is it emotional? Is it psychological? Is it verbal? Is it sexual? Is it stalking? What is it exactly? Right. So and this is something, a game that many authors play on, because they give a very big vague title in the hope of getting more readers to read the article, but they don't give accurate, well-proportioned definition. So if they if they include everything in the abuse, even the verbal, even the sexual, even the talking, even some maybe stalking, even, then yeah, you'll have a huge number of people who are being abused. Okay, but maybe 90% of those cases are, I would say, benign cases, are mild cases. Okay, they may not require huge resources to be spent to try to resolve them. I'm not saying that stalking is a good thing, but I'm just saying that we cannot say stalking is equal to rape. Okay, so rape is a huge, big problem that requires attention and resources to be dedicated to solve it, more than just stalking that can be solved maybe with some minor intervention. Okay, so what many people do, what many authors do, actually they do a horrible thing. So they give a very broad definition of the problem, of the social problem, and then within their article they give a case of a severe situation, like maybe a woman who was severely abused for so many years by her husband. Maybe she was raped, maybe she was physically tortured. Okay, what the reader will assume in that case is that the whole big number of people who's covered by this broad definition, they have similar kind of horrific treatment. Okay, so this is what also another reason why we have mistakes in non-statistical reports. Okay, so another issue is the measurement. How do we measure the problem? So we have, depending on how you measure the issue, basically you get a different result. For example, if you are talking about abortion and we say, do you support abortion, for example? Well, you know, if you say, if you give only 2 options, yes and no, most likely 95% they will say, in conservative society, 95% will most likely say no, they don't support abortion. Okay, but if you ask the same question and you say, do you support abortion? And then you give 3 options, yes, no, and only in some medical emergencies, well, only 20% will say no in this case. So you changed public opinion on some important matter by just manipulating the options that you include in your survey. Okay, so it's very crucial that you really make a well valid and reliable survey. Those are important terms you need to remember: valid and reliable surveys that actually cover the issue that you are dealing with based on the definition that you have proposed. Another issue is sampling. Okay, are you choosing the right sample size? Okay, are you choosing the right sample size? And there are many different approaches of choosing the right sample size. Basically, you need to first, of course, the research problem matters on how many people you actually include in your sample. Basically, what kind of statistical analysis you are conducting also has an impact. Basically, the nature of the population makes a difference as well. Is it the population is it homogeneous or is it heterogeneous? Do you have many subgroups, or it's only one major group? So these are all many different considerations. Of course, we don't have time to go through how we choose the right sample, but there are many other courses to address that. But you really have to make sure that this article that people are talking about, they chose the size of the sample in the right way. And another issue that goes along with the sample size is the sample method. Okay, are you choosing cluster sampling? Are you choosing random sampling? Are you choosing convenience sampling? And why are you, and is this stated in the article? Like, do the people say how they chose this sample? Because they have to. Okay, if they didn't say how they collected these individuals in their sample, then there's an issue in that. So these are also important issues that people can miss or like don't represent in their articles that they are writing. Another issue is data cleaning. Okay, you collect the data. Did the researchers, did the scientist, the statistician clean the data before he conducts the analysis? What do we mean by data cleaning? Okay, so most likely in any study we do, we have some outliers. Outliers are extreme values that may or may not make sense. Okay, so sometimes they are due to some errors, systematic errors or human errors, and then maybe they need to be eliminated. Okay, first you have just to justify that. Okay, there's no way someone can make $1 billion per month as a salary. Okay, let's say in a limited economy. Okay, there's no way. So this must have been a mistake. Okay, but sometimes actually it's legitimate. Okay, it's something that you just ask a person who has very high salary. Maybe it's not a $1 billion, but maybe it's $100,000 per month. Okay, where are all other people in the samples? Maybe they earn a couple of thousands, but this individual, maybe he's ultra rich, who happened to be in that neighborhood, who just makes that much money. Okay, so now you cannot eliminate it. All right, and you need to justify whether you want to keep it or you want to eliminate it. Then you have to present your considerations. Okay, sometimes actually the outlier happened because some exceptional thing happened. Okay, maybe on that day that maybe it's a many days survey, but on one day something happened really. Maybe some earthquake happened, and this biased people's opinions on certain matters that you're asking about. Okay, so this is one aspect. Another aspect is the missing values. Missing values are crucial, okay? And we should really deal with them in a very delicate way, because also we have two reasons why data can be missing. Maybe because it's a systematic error, because people just when you are carrying data from the paper maybe to the computer, maybe the computer didn't read it very well, or maybe the human who was filling the survey, he just missed that question. That's of course you maybe deal with it in a specific way. Maybe you eliminate the question for that specific individual, or you eliminate the survey for the question for that specific individual. You can just deal with it in some different ways. But when this missing variable is repetitive, now that's another issue. Okay, that raises bigger questions. And because they may indicate a sensitive question. So if I'm asking, for example, about drug use or maybe sexuality, these are very specific and sensitive questions. So when people refuse to answer this question, Okay, and you have, let's say, 10-15% rate of missing answers on that specific questions. This says a lot about your whole study. If 15% of people refuse to answer their experience with drugs before, okay, and you just relied on the other 85% and you want to make generalization, you are making a mistake. You are making a crucial mistake. No, in that case, you'll have to reconsider the whole survey, because even those who answered this question may have answered it under the pressure of social pressure, and they gave wrong results. So when this missing variable is missing and it's in a repetitive way, and it's due most likely to sensitive issues, you will have to reconsider the whole survey. It might actually be totally disqualified. So that's why it's important to know what questions to ask and how to ask them. Okay, another issue is using the right statistical technique based on the figures that you have, whether you have outliers or you don't have outliers. If you are, for example, dealing with single variable statistics, and you have outliers, you have extreme values. For example, you cannot use mean. It's better to use median. Look at this example here. So this here gives us an idea of the discrepancies between how families are worth in the United States. So it says that the average is 1.06 million, okay, but the median is 192,000. There's a huge difference. So if I go and say, you know what, the average net worth of US families is $1 million, this will give you a very different perspective of US families than saying it's only 192,000 dollars for each family. Okay, but which one of them is more accurate? Of course, in this case, the median is more accurate. Okay, because you have some extreme values. So reporting the mean and ignoring the median in such a case, you'll be also committing another mistake. Another issue, basically, did we include all the right variables in our study? Okay, so basically, if we are dealing with multivariate analysis, it's important when we are trying to see the relationship between X and Y, whether, because people will always try to assume, for example, if you look at this graph here, this is a mockery graph. This graph actually talks about two variables, ice cream and crime rate, okay? And for unsuspecting eyes, they will say, okay, well, you know what? Those two curves just follow each other very vividly. So most likely, maybe crime rate is influenced by ice cream sales, or the other way around. But this is also a mistake, because both of them are actually influenced by heat, which is here. So heat is the contributing factor of changing crime rate. Heat is also the contributing factor in changing ice cream adoption or ice cream sales. Okay, but because they change in the similar manner, we think or we feel that they are actually related to each other. And that's what many, unfortunately, journalists do. Okay, so they bring two variables, and now in this case, of course, it's very obvious there's no relationship. But sometimes the relationship is subtle. Okay, so and they try to convince you that there's a relationship between two things, but there's actually no relationship, and there's an intervening variable behind which is influencing both at the same time. For that, actually, this was an interesting topic for a guy called Tyler Vegan. He has a blog which discusses specifically this point. What he does, he has a huge data set of so many different variables. And we're talking about tens of thousands of variables. He puts them in his system and he analyzes them, and he comes up with all those silly correlations. For example, if you look at this title here, I cannot see it very well, but let me just do it like this. Okay, so master's degree awarded in psychology correlates with Amazon.com stock prices. Those two variables have nothing to do with each other, but based on the data that he collected, actually they are correlated. Okay, so this is another thing that people do as a mistake. So what people do, they confuse correlation with causation. They think things correlate. This means that they are one is leading to the other. So this guy has a very interesting blog where actually he introduces very funny correlations between different variables. The correlations are accurate, but what's not true is the causation. There's no causation between those different variables. Finally, another slide on interpretation. If you look at this graph here and this graph here, so the only difference between them is one is starting from a 0 and the other is starting from 80. The one starting from 80, you will get the impression that product A is very different from product B. Okay, but here you will see that product A is not that different from product B. Why? Because actually the graph here starts from 0. So if you want to give the impression for people that there is a difference between figures in this case, or case in this case A and B, you will just give this graph here. If you want to make more realistic, correct approach, you will just present it accurately by starting with the origin by 0. Okay, so this is the second section. The third section, how do we do professional graph? How do we make it look? So here we'll talk about the aesthetics and the criteria of creating a nice, attractive looking graphs, and then we will talk a little bit about what to say in which part of the academic publication. First thing we have to understand is that when we are talking about graphs, we need to know what is the key message that we want to send to the viewer, okay, to the reader. Okay, so this is number one thing that we have to keep in mind. The graphs are not supposed to give like detailed view of everything. Here in this graph, all what I wanted to cover is basically in year 2016, the internet advertising succeeded for the first time the television advertising. Are there more things to see in this graph? Of course there are. We can see the slope. We can see how the internet actually is a bit steeper. We can see that both of them are still increasing. There's no decrease in any one of them. They are both increasing, but the internet is increasing in a faster rate. We can take all of those messages, and that's the beauty of a graph. The beauty of a graph, you give the most important message, you highlight it, but you let it to the reader. If you want to go a little bit further and to get more context, it's up to them to read more carefully and vividly and in detailed way in the graph to see more results. But graphs are not always the best way to express, like we said before when I started this presentation. There are other ways to present the graph. Okay, when we are putting the graph, you have to think, will this graph increase our comprehension of the information? Will it highlight trends and relationship? Will it be in a concise and space efficient way, like the example which I gave before about the text which can be represented in 1 or 2 words rather than a huge graph? Does it enhance engagement? People will be more happy to read more into it. Will we be able to reach wider audience through it? So all of these must apply, or at least few of them at least must apply in order to create a graph. So we should avoid graphs when the data can easily be summarized in a single sentence or few sentences. The graph doesn't reveal any significant trend of relationships, or the message isn't significant for the main narrative. If I'm just giving some graph just because I have the data and I will just put it there, that's not good. I'm wasting my readers' time. My readers' time is precious, and I'm wasting it by just putting non-relevant data just because I have it. Okay. Another part is understanding what graph do we need for each problem or each purpose. If we want to show trends over time, then the best is to use a line graph, and for that we need continuous data. Okay, so if we are categorizing or comparing between categories, then bar charts, whether it's vertical or horizontal, is the best way. If we are showing distributions, then histogram or box plots are appropriate. If we are showing relationship between two numerical variables, then scatter plot is good. If we are showing relationship between three numerical variables, then we can do the bubble chart. And if we are showing part to a whole relationship, so what is this compared to other parts of the variables that we are discussing, then a pie chart is good, or stack chart. I say pie chart to use with caution because sometimes it's misused. Like sometimes you have a pie chart and then you have some items within this pie chart which takes like 1 or 2%, and then it will look not nice. Okay? It will not look nice. It will look a bit ugly. But if you really have to, and there's no other way to express what you want to say, maybe do it, but do it in a try to make it as elegant as possible. Okay, so pie charts are one of those charts which are overused charts, and I would say try to use them with caution. And then we have the stacked area chart if we have time involved, if we have multiple categories involved, so each category will take a certain color, and then if we have numeric variable involved. So we have time as one variable, we have categories as a categorical variable as another variable, and we have a numerical variable as the third variable. So when we have something like this, stacked area chart will be good. And then we have the heat map. Of course, we use if you have one variable, but we have a geographical map. We are trying to map those numbers into a geographical map. And then if we want to make some hierarchical structure, this is not very frequently used because it's a little bit difficult to grasp, but we have the sunburst chart. Okay, so those are the different types. What about the titles? Title be clear and concise as much as you can. Try to be consistent regarding the formatting and the placement, and avoid redundancy. Okay, so you cannot just put the title and then put a title for the chart below it, and then also do the same thing on the axis. Don't be repetitive. Okay, so make the title as expressive as possible, as detailed as possible, but also make it concise. For example, instead of saying sales, use, for example, monthly sales performance for product A, and if we are talking here about the time frame, we put just the time frame here. Okay. What about data points and labels? Again, more is less when it comes to graphs. Not just because you have the data, this means that you need to put it. Not just because the software that you are using for visualization allows you to easily put more things on the graph, that you go ahead and put more things. That's not the point. What's the point is, if you have a specific message that you want to send to the reader, how would you send this message in the best way possible, in the most efficient way possible? If you look at this example here, I think the second graph is better than the first graph. Okay, so why would I want to put the data points here for each one of them? It's just too redundant. I'm making a graph to get an overview. Okay, how things improved in the last 30 or 40 years. Okay, so in this case, less data points and also less labels as well. So here I can look at it and I can just right away know that how much difference there was. What I put data labels here for was two things: the highest and the lowest, and that's it. Okay, so this is one way to put the labels. If you maybe want to highlight specific bar, you can also put the labels there. If you want to if you want to make certain contrast, you can also make the label. So try to avoid clutter and try to avoid redundancies as much as possible, and make it very readable to the biggest extent. X and Y axis. Okay, that's very relevant to look at those graphs here. Okay, these are all the same figures. They are the same numbers. But because the aspect ratio between X and Y is different, okay, you will get a totally different image or view of what's happening in reality. You could say, well, you know what, but if I read into it, the numbers, the figures, then I will also be able to tell that actually it's the same. I say yes, but that's not what the graphs are supposed to do. The graphs are supposed to give you a quick overview of the situation without you putting this extra effort to understand what each data point that you have leads to. Okay, so what's the best aspect ratio between X and Y? Here, there's no rule of the proportion between the X and Y, but there are just general rules of thumb. Like, it depends on maybe the publication, on the data set that you are doing. It depends on the domain that you are in. But I would say 1-to-1, like the first graph here. Okay, of course, this is the best one out of the three. Okay, it gives more realistic situation. It just gives you for the months between February and July, things were almost similar, and then after July things dipped, okay, very severely. So I would say in this case 1-to-1 ratio was good, or 16-to-9, or 1.5-to-1. So these are some general rule of thumbs that you can use in doing the X and Y axis. Regarding the titles, titles are good option to make things clear, but be consistent and avoid very obvious data like this one here. Why do we need gender? Okay, male and female, it's obvious we are talking about gender here. Okay, so again, does it matter? I think yes, it matters. You could just you have more professional by just not going into those filling the graphs with useless things. Okay, so put an axis to explain what this axis is about, put an axis title to explain what this axis is all about. But when it's very obvious or it's too obvious, don't just put axis titles. Make it just people, readers will understand what you mean. Colors, grid lines, and backgrounds. Again, look at those two different charts here. Okay, so this is something that's just I think just out of Excel chart. So you have the chart and you click chart and Excel will give you this. Okay, don't just take it as it is and put it in your publication. I think it will also be rejected. Try to make the colors as much as you can. Use the gray shades, okay, like this. Make the gaps between the bars as small as possible. Make them more compact. Of course, this legend here is stupid. Of course, Excel gives it to you, and there is no need at all for the legend in this case. The title here is also, it has to be changed. Basically, the grid lines that are here, I feel that they are very distracting. There is no reason. I don't want to exactly know what this value here. Okay, I just want to know, roughly speaking, that Samsung is way more than iPhone, is way more than BlackBerry. That's what I want to know. And then make, of course, the background white. Okay, so basically these are also useful remarks when you are doing publications. I think people, reviewers will appreciate doing it the second way rather than the first way. Okay, so a couple of slides regarding what to put in which part of the academic papers. No, I have 5 more minutes left. Okay, I will be really quick. Okay, so first of all, the king is the academic journal guidelines. So you have to go to the journal guidelines. Most likely they will have some references on how your graphs should be presented, how statistics should be presented, how tables should be presented. So this is number 1 criteria. Okay, whatever I say now, whatever any person says, what matters the most is what the reviewers at the journal say. Okay, but this being said, there are some general remarks on what to say and what to do in your academic papers. First, basically, you have to ensure that you have some consistency throughout the manuscript. Consistency in 2 things, and the figures that you are giving. So there's no contradicting figures between different sections, and figures in the format. Okay, so and the style of the presentations, and the graphs, and the tables, and the fonts that you use. So this has to be really consistent so that people don't be misled. The p-value alone is not sufficient. Always have some descriptive statistics. This p-value is one of the values which are also overused one. It's abused value, because people say, okay, well, I have a p-value of less than 0.05. This means I'm good. No, it's not good enough. There are many reasons why you'll have p of less than 0.05, but your data should still be subjected to certain scrutiny. Okay, so always include some descriptive statistics. So in that abstract, mention the key findings that you have, put some limited interpretations and the significance of the results that you got, okay? The p-value, okay, if you want to say. In the methodology section, describe your sample, the size, how did you choose it, what people were included, what people were excluded, and the sampling method that you chose. In the measurement part, in the methodology section, so we are talking here about the survey, okay? If you have some reliability, Cronbach alpha value, you need to put it there. And if you did some validity study on that survey, also put it there. And of course, I highly recommend that you do both. When you're talking about some instrument, or you may be already taking some already established instrument before, which has proven record of high reliability and validity. In the analysis section, you go back to the what assumption that you had, the hypothesis that you presented, the statistical techniques that you used, the models, the level of significance, and how you handled missing data. Okay, and in the results sections, you present the descriptive statistics. You present again. You rewrite the hypothesis that you have now with the results of them. So if you used, let's say, t-test, you will say, okay, well, I use t-test to see whether there's a difference between mean between the group A and B, and this is my result, and this is my it's significantly let's say group A is different from group B, and this is my p-value, and so on. Okay, and in this section you also present your graphs and visuals, and you avoid going into too much discussions and interpretations. In this section, you leave it to the discussion sections. What is the interpretation of what you did before? Did your results match with other researchers before you? Do they make sense? What kind of implications they have in the industry or in the academic community? Okay, what future doors would your results open for future researchers? What were the limitations? What could you have done better? So those all need to be left to the discussion sections, and this is, I feel, this is the most important section. I didn't want to put it as a conclusion. So some people say it's conclusion section. Some people put it as a discussion, separate discussion section. It depends how you frame it. But the section which handles these aspects here, I think, is extremely important for me. If I want to read one section throughout the whole of the whole article, this is the section that I'm gonna read. Okay, finally, I will just take a couple of minutes to go through visualization and AI. Okay, so basically, the current visualization tools that we already have, they are very powerful. So when we are talking about Excel, Tableau, SPSS, SAS, Stata, and so on, for academic writers and industry practitioners, they are really good. They were always good. Okay, so what those text-based AI tools that they didn't really gave us so much. Okay, so those tools that I just mentioned, they offer mid-level control over visuals. Okay, so you don't have, like, you cannot manipulate deeply how those graphs are presented. So there are some differences between them. For example, SPSS, you have a little bit less appealing visuals when you compare them to Tableau, for example. Excel actually is better for visualization, in my point of view, than SPSS in certain variables. So they are different in between each other, but mostly they offer mid-level control. You can actually control how they look, like what we did with the Excel graph that I showed you before. It will look more friendly, more, and these tools are really not hard to learn. Okay, if you want to have more control, you need to go through, you need to understand lower level languages like Python, R, MATLAB, and so on, which will give you 100% control of everything. Okay, but the problem is with those languages, you have a steeper learning curve. Okay, it's harder to learn. But what we'll also get as an advantage is you will have some better web integration, so you can present those graphs on web, and you can have that. If you are writing for web articles, people can interact with them in an easier way. Now, what about AI tools? As I said, those tools wouldn't give us a lot that we didn't have before. We had everything before. But what they could give us, for example, very rough graph of, for example, if we have some data, okay, and we want to know, generally speaking, what kind of things that this data is going to tell us about. Maybe it's a good idea, throw this data in ChatGPT or Gemini or Copilot or those popular tools and see what they will tell us. Okay, those tools will give us certain general overview of the data that we have, some graphs that we can use, but they have very limited customization. They are less able to be consistent throughout the report, because if you create one graph like this, maybe the other graph that you will create will have different visuals. You cannot control it at all. You'll probably end up taking more time to produce the graphs that you could have done in those mentioned tools before. As I said, they are good for overall understanding and summarization of data, but basically they are still inferior to already existing visualization tool that I mentioned. I'll give you an example. So, for example, look at this chart here. I put this here. I think I used Gemini for this example. Look, and then they asked them to give me some box plot. They gave me this one first, and then I didn't like it that much because I wanted more labels, and then they gave me this one here again. Okay, so first of all, they gave it to me as an image. Okay, so if I want to change this for the title here, okay, here's the title. So monthly rent distribution by vacancy status. Monthly rent distribution by vacancy. I don't like the word with labels here, so I need to omit it. So I need to go to visuals and to go to some graphical editing software to remove this. Okay. Another issue, when I included the labels here, look at this thing here. Okay. So here we have the median and the mean. They are on top of each other. So again, if I want to fix it, I need to go to a user interface, a graphical user interface, and edit the stuff and do it in a more appealing way. This will take me more time than actually going to Excel, doing it in Excel or doing it in SPSS, to be honest. So yes, use AI tools, but use it with caution, because sometimes they also do mistakes and they do interpretation mistakes. For example, what we have here, but I would say just go back to the software that have a better performance overall, which I mentioned before. But this is a slide, just a final slide. I just want to say that regarding a relationship between variables here, I have, for example, a research question. This is all made up research question. I have, for example, attitude of users toward a mobile game, and the more specifically, what is the impact of ads on the attitude of users toward mobile games? I collected data and I uploaded it. I asked Copilot to analyze the data for me, and they gave me those results. Okay, fine, looks good, interesting, but this is on the bright side, all right? On the dark side, Copilot doesn't have the theoretical background to tell me exactly that the relationship, for example, between quitting and age group is a reliable relationship. Maybe, for example, this applies more for men and less for women, for example. Okay, maybe there are some other variables that is influencing those two together that I cannot see. Okay, so AI user interface are not designed to create conclusive remarks regarding the data set. In some instances, AI may lead to wrong conclusions. So I would say, in conclusion, use AI with caution, whether you are doing interpretations or whether you are doing it for visualizations. In both cases, use it with caution. And those are two sets of graphs that I'm not going to go into. Maybe I don't know if you share it with the audience, of what AI can do and what AI cannot do as of now. Okay, thank you so much. I know I took more time than I should, but I just couldn't stop. Sorry for that.
Thank you so much. This was really, really very interesting and very comprehensive. Really appreciate your thought and the in-depth analysis that you have offered to the audience. Although this was really brilliant and engaging, and but we still have questions, of course. You clearly unpacked complex issues like how data can be misinterpreted, the importance of choosing the right visuals. I particularly enjoyed that because, you see, coming from a qualitative research background, I think we really don't understand and cannot differentiate between different types of tables and graphs and how they represent or can impact the data interpretation for the reader. So starting on with the questions, I'm going to take the first question, which is a very basic kind of a question that what's the difference between ANCOVA and ANOVA? And how should we reconsider the assumptions and applications when we are working with these particular tests in quantitative analysis?
Okay, so basically ANOVA is basically, it's unlike what the name says, ANOVA is not study of variances. ANOVA is, we do it to study different means. So if we have 3 or more means, just if we have more 3 or more means in our data set, for example, a very common example for ANOVA is basically when we are doing treatment of farms. Okay, so we have plot A, plot B, and plot C, and we put certain fertilizer in plot A, and another fertilizer in plot B, another fertilizer in plot C, and we see the results. And then if there is And if we see there's a significant difference between the different plots, means that at least one of those lands is different from the others. So this is what ANOVA is. What was the other thing?
ANCOVA.
So ANCOVA is basically ANCOVA is similar to the ANOVA study, but the difference is that we are studying here we are studying the variances between the different factors. So for example, if we go back to our original problems, we have the three different lands, and we want to see whether land A and land B, the variance between them are different from land B and land C, and land C and land A. So we have three different lands. In ANOVA, we say whether the mean of land A different from land B, different from land B. But with analysis of covariance, basically we are studying whether the variation between A and B is different from A and C and different from B and C. I'm not sure if this is clear.
Thank you so much. Going even, further, just backtracking in the research process, the very confusing aspect for young researchers is how to choose the relevant statistical test based on their own hypotheses. Any tips for researchers there?
Basically, the more the short answer is basically experience. I would say if you have, for example, let's assume that I will just make a very simple example. Let's assume the only measure of central tendency is mean. Okay, so and I tell you I want to know the difference between two set of groups, whether there are difference in the means between them or not, on the averages between them or not. So because the only metric is means, the first thing you will go to is analysis of means. Okay, but if you have if you know that in cases where we have extreme values, that analysis of means is not sufficient, then you will go for analysis of medians. Another example, if for example you want to the difference between regression and let's say logistic regression and the normal regression. Okay, so if you if there's if the only thing is regression, then some simple linear regression or multiple regression with multiple variables, then whatever you are faced with, you will see it through the lens of multiple linear regression. Okay, but once you understand that there's another method called logistic regression, where actually for dependent variable which is dichotomous, it's better suited, then you will use that method to study that specific incident. So I would say the more you know, the better you will be able to handle situation that you will be encountered with. So what I would usually do, so if I'm reading about certain situation or in a certain setting or in a certain area or paradigm, for example, I'm studying consumer behavior, I know the previous authors, they use, for example, factor analysis to deal with situation very similar to mine. Okay, and I will use factor analysis. But then I come across another method, which is the principal component method. Okay, and then I will see, okay, well, you know what, this method is better suited for my specific incident, so I will use that other method. So this is how I would summarize my answer to this question.
Thank you so much. We have another question. which is also very basic yet critical. How many tables and figures do you think should be, appropriately included in a manuscript?
The simple answer would be how, basically, is if you go back to the guidelines of the journal, if there are some guidelines which talk about that in the journal, that I think makes it easier. But if I would say that this also depends on how many variables you have also in the survey. The way I would just express it is whatever. This is basically something I was hinting at throughout my talk today. If having 10 tables is a good expression of what I want to deliver, then let it be. If 5 graphs is good, then let it be. What the question, what we should be addressing really is what is the better approach to send my narrative to the readers.
Yes.
So I couldn't say that, okay, you know what, this is the number of tables that I need to have, because as I said, it depends on the variables that I have, depends on the type of journal that I'm writing in, but also on my way of representing data.
Definitely. And I think that data should be presented clearly, transparently, and also in an easy to understand way, so that readers can follow you. And too many tables, too many, especially the tables, maybe the graphs can add to the quality of your manuscript, but too many tables may confuse the reader. And going back to what Dr. Nasser just said, that it really, it depends on the journal that you are approaching and the need of your research. So now we have many questions relating graphical representation and visualization. So the first one is that what is the most effective way to visualize a randomized controlled trial comparing an intervention group and a control group?
Can you say please again one more time?
Sure. So what is the most effective way to visualize a randomized controlled trial comparing an intervention group and control group?
But this is the thing. If you go back to my slides on representation, it's not about what is whether I'm representing a control versus an intervention group. It's more about the type of variables that I'm addressing. Am I talking about a quantitative variable or is it a categorical variable? Is it something that has a time frame, or is it something without a time frame? So basically, this is the main contributor to choosing the right representation, and not whether it's because we are talking about an experimental design. Okay, and basically, I don't have ideas of if it's like they are dealing with, for example, smoking addiction, or how many times they smoke per day. Maybe a bar graph is good, because you just put them next to each other, and then it will be. And bar graph is a representation of a categorical variable. Then it would be a nice way to represent that, for example.
All right. The next question that is related to graphical representation is that in your conversation, you said that colors can influence the way the data is being interpreted by the reader. Can you elaborate on this idea that colors convey a message?
Yes, so basically what I frequently encounter in my when I'm supervising students at the university is students who actually have different colors and different graphs. So for example, let's say they are talking about studying behavior, and they are expressing how different, let's say, different times of the day and how much they have focus, for example. It's just an example. And then they present this in blue color. Okay, and then one section after, they present a similar graph, but maybe the amount of leisure time, and they present it in a green color. Okay. And I just tell them, why did you choose blue here? And then why did you choose green there? Okay, and usually they don't have a reason, they don't have an answer. And they just wanted to, they say, I wanted to make it aesthetically more pleasing and enjoyable. And I say, if colors actually compete with every other information available in your document for my attention. So since I thought about it, since it's something that we do it in a very subtle way. We don't really think of it consciously, like we say, oh, why it's blue and why it's color. But for every reader, there's some few seconds that they spend trying to make sense of why was it blue there and why was it pink there or green there. So I want to avoid that. And this is the most basic way that colors can intervene. And sometimes it can actually be misleading. Okay, so if I just have, let's say, 4 different colors in my bar graph, and I'm trying to, and there's no reason of course, if there are reasons to have those colors, then let it be. But if the colors are there just to make the graph look better, then no, let's omit it. Let's stick to
I agree with you. Yeah. I just want to add here that colors really do convey a message. Sometimes colors entail a specific meaning in different cultures or maybe in global context. For example, red or the deep red color often signals danger or a drop. So I would not use red in the graphs, whereas green suggests growth, positivity, improvement. So yeah, colors can offer a visual cue in data visualization.
I
So
agree
moving on to
100%.
moving on to the next question. Is it possible to use all types of graphs for one data set? Is it possible?
Again, it's all about the context. If I am doing a very thorough correlation analysis between so many different variables, I cannot see a practical setting why this can be done. But I don't see why not. If this is what you are doing. So for me, graphs and tables are never the end result. It's just a very small tool to convey a message. So if my message, that's the best way to, is just putting one, let's say, scatter plot after another. I don't see why not. Of course, the author need to consider that this is something that can be a little bit boring to the audience, that they are going through all of that. But he has to think about it, and then he has to settle to the idea that, I know it's a little bit boring, but there's no other way for me to do it, so I will just have to put it this way. This is kind of the sort of internal struggle that the author has to do, to think about all those considerations before deciding to put those repetitive graphs in his paper.
Thank you so much for clarifying this. Last question, could you please elaborate on some of the ethical challenges that researchers may encounter with while they are presenting the data?
First, I think that's what we call as, there's the cherry picking. I think this is, for me, the worst attitude. I think many scholars go under the pressure of publications. They have to publish, and for them to be able to publish, they have to come up with something interesting. And that something which is interesting usually is not something which is common. Okay, so then they maybe decide to choose. What do I mean by cherry picking? I mean maybe choosing a sample that will reflect what you want to have in your results, rather than 100% random and valid sample. Another issue is basically, first you run the analysis, you get the hypothesis, and then you manipulate the hypothesis and the narrative to suit the data and not the other way around. I also find this behavior happening frequently. and I believe in that's not a good etiquette that scholars need to live by. Then, of course, basically relying too much on the p-value and assuming the p-value is just what will make or break their entire narrative. And I also don't like it because, yes, basically we have the p-value just to guide us whether the hypothesis is significant or not. But the context is very important. The other descriptive statistics is very important.
Answer. This brings us to the end of this webinar. I would like to thank you once again on behalf of the Center for Learning and Teaching, and Dr. Ruxana asked me to extend her sincerest gratitude for you. She had a prior appointment which could not be rescheduled, but she sends her best regards to you. And
Thank
just
you.
to give you an overview, we had participation from 16 different countries, ranging across Asia, African region, Europe, and South America. So thank you so much for sharing your knowledge with us, and we hope to stay connected with you. We hope to, keep on collaborating with you on different events. For my audience, I want to remind you that today we have come to an end of the tools for research. And from Monday onwards, we are going to start the next module, which focuses on writing skills. On Monday, our webinar will be scheduled at 11 a.m. Pakistani time. And the title of this webinar is Research, Writing, and Publishing for Humanities. Our resource persons are renowned researchers from Pakistan. We hope to see you in the next session. So thank you so much. Enjoy your evening, everyone. And thank you once again, Dr. Nasser.
Thank you so much for your patience, and thank you for all the audience.
Yeah. Thanks again.